We'll make our imports. So these are all the packages that I mentioned before. We've got the text-to-speech package, we've got the threading package, and we've got the speech recognition package. And let's start building our conversation class. So this conversation class is going to manage the conversation with the computer. It's also going to manage the lifetime for which the microphone is open and how all of the speech inputs that I provide is added to the queue, and then how this queue is then processed as well. So a few things that I'm initializing here. I'm going to initialize a flag, which will then tell the conversation manager when to stop listening. So when we initialize this conversation manager, it'll be set to false, meaning that it should start listening. But then there'll be a few different instances within the code where this flag will then be changed to true, which will then mean that the conversation manager can stop listening and the microphone can be closed. This energy threshold is quite an important property, and this is used by the speech recognition library basically to initialize and to calibrate the microphone when the microphone is opened. Energy in this case is kind of a measure of how much noise or activity is going on around the microphone. So therefore, when we open up the microphone, you'll notice that the microphone does a bit of calibration. And this is really to try and block out any noise that's around the mic. We've then got our speech queue here, which will store the queue of all of the processes that need to be executed. And we're also going to initialize the LLM manager here as well. The next thing that we're going to add is the continuous listen method. There's several helper methods that I'm going to include in this class, and then there's only one method that we'll use in the actual main file. All of these helper methods will essentially be used to run the whole application. What's happening here is that when this method is called, it opens up the speech recognizer, it opens up the microphone, and it also sets the energy threshold that we decided before. We then define another function within this method, which is essentially our continuous listening loop. When this is running, as you can see here, it will adjust for ambient noise. It uses a certain threshold of time to take in the noise around the microphone, and it will adjust the sensitivity of the speech recognition based on the surrounding noise. As you can see from this while loop here, this is basically going to carry on continuously until the stop listening flag gets changed to true. And what's happening here is that the audio is being recognized by the speech recognition library. It's then passing it to the Google Speech API, which is then converting that audio into text. And one nice benefit of the way that I've set this up is that the audio is not being saved locally on the machine. You can use other libraries and this library as well to save the files on the machine, but this is intended to be as lightweight as possible. So actually the raw audio is sent to Google, and then Google is transforming that into text. Then we get our transcript, and this transcript is added to our speech queue. And once this gets added to the speech queue, then it will be processed using the threads. We have some error handling at the bottom here as well. And then finally, outside of the listen loop, we're just initializing the listen loop in a separate thread, which will allow it to be executed in the background. So the next helper method is the process speech method. Now what's going on here is, once again, we have another while loop. While we are listening, we take the transcript from the queue. This is constantly waiting for a transcript to be added to the queue. As soon as a transcript is added to the queue, all of this remaining code is then executed. First of all, it checks to make sure that there is actually some valid text on the transcript. If not, then it will come back with some error handling. If there is valid text, then it's going to send the text to the LLM manager using the method that we set up before. So if I just click through on this, go to process user input, the transcript is then being sent to this method here, along with the current basket that the LLM manager is maintaining. When we get the response back, we extract the intent from the response. And this is obviously based off the JSON structure that we're asking the LLM to provide back to us. And based on the intent, we're taking various actions. So for example, if the query is invalid, the computer will say, this is an invalid query, try something else. And then we can add as many different blocks here as we want for all the different intents. For each of these intents, various things are happening, such as if I clear the basket, it's going to reset the basket and start again. And if I'm adding or updating an item, then the basket will get updated as well. And this is handled at the bottom here. I also have an intent to be able to exit the application, which will break the loop, update the stop listening flag to true, and exit the application. So this method handles what the computer is doing once it receives the response from the LLM. Finally, there's two other helper methods that I'm going to add. You may have seen some of these helper methods being used already, which I'm going to explain now. We have a speak response method. And let me just uncomment these lines here. This speak response method, as I said to you, with this application that you can run on your computer, you can speak to the computer and the computer can actually speak back to you. The computer is going to be using a very basic voice, but you can swap this out for any other kind of voice that you want to, or audio files if you wish. So this speak response method will provide a spoken response back to me as the user based on the intent I have just requested. And once again, this is all being executed in the background in a separate thread, which means that it's non-blocking. So if the computer happens to be speaking to me and I decide that I want to start speaking back to it, it will be listening at the same time as it's talking. And then finally, the save state method. This is just a simple helper method that when I make a request to the computer, it will save the current request in this response.json file locally on your computer. So you can keep opening this up to check what the computer is processing. So that's all the helper methods. The last thing that we need to copy over is the start method. And this is the actual main entry point that we'll use to run the application in terms of this class at least. So I'm going to put this at the top. Essentially what this is doing is it's calling the continuous listen method. It's adding another thread for the speech events. And then it's basically setting up a continuous listening loop until somebody says that they no longer want to use the application or exits the application. So that's all the code that we need in the conversation class. Finally, we're going to fill in the main module, which will be the entry point that we use from the terminal. This is very simple. This is just importing the various classes that we've created and setting up the module so that we instantiate the classes, we instantiate the queue as well, and then we start the conversation manager. This makes for a really concise and clean entry point for our application. Everything is abstracted away in these various classes.